Hi everyone, in this video we are going to look at the second half of 4.5. You'll remember that in Mrs. Bixler's recent video she taught you the first half, which is about absolute value equations, and today we are going to look at squared equations. So you might be wondering why squared equations are included in the same section as absolute value equations, and here's the reason why. You know that in order to undo a perfect square or a square, remember that's our exponent of 2, we are going to take the square root of both sides of the equation. That means that we're looking for what times what equals 25. So what we're going to do here is we are actually going to turn this situation here into the absolute value of x. And I know the square root of 25 is 5. The reason for that is that it is going to help us remember to think about both our positive solution and our negative solution. Because if I have the absolute value of x equals 5, I know that x is either going to be 5 or negative 5. So what happens is that when I say that for all values of x, the square root of x squared is the same as the absolute value of x, it's helping us to remember both our positive and our negative solution. Remember, absolute value is a number's distance from 0, and both 5 and negative 5 are 5 spots away from 0. So hopefully this helps, and we're going to continue to keep this rule in mind. So we had the square root, x squared, equals 81. We are going to square root both sides, and I'm going to turn the left-hand side into the absolute value of x, and I know the square root of 81 is 9. Well, if the absolute value of x equals 9, then I know that both 9 and negative 9 are 9 spots away from 0. So I have two solutions here. Just like you had absolute value two solutions, we're looking for two solutions with our squared equations as well. So now we're getting a little fancier. Now I have a larger thing to take the square root of. I take the square root of the entire thing, which means the entire thing goes inside my absolute value symbol. The square root of 81 is 9. And so now I'm thinking about two equations, right? Just like you made with in Mrs. Bixler's video. So x plus 2 equals 9, or x plus 2 equals negative 9. So I would subtract 2 on both sides. So one solution is going to be x equals 7, or my other solution is going to be x equals negative 11. So again, we're getting fancy with what's inside our squared. So I'm going to square root both sides, and I want you to now pause, and I want you to try this one on your own. All right, so hopefully this made sense. You square root of both sides, which then left you with this absolute value, and the square root of 25 being 5, which then made us two equations of 3x minus 4 equals 5 and 3x minus 4 equals negative 5, which then got us to two solutions of 3 or negative 1/3. All right, so now it gets a little trickier in that what is part of our equation is more than just the squared portion. And what you're going to hear me say over these next couple slides is to isolate the weird guy. The weird part of this equation is the x squared. The 5 we know is attached with multiplication, and I know that I can easily get rid of that by dividing by 5 on both sides. Now I'm at x squared equals 9, and I've successfully isolated the weird guy, the squared portion. I've gotten it by itself. I now know that I'm going to square root both sides, which is going to leave me with the absolute value of x equals 3, which tells me that x can either be 3 or negative 3. So now it gets tricky. And what we have to notice, again, is that we have our weird guy, and we have two things going on. We have subtraction, and there's invisible multiplication right here. And just like when we're solving a regular equation, we are going to solve this according to backwards PEMDAS. So I'm first going to add 6 to both sides and begin to isolate the weird guy. That's going to leave me with 7 times x plus 3 quantity squared equals 63. In order to get rid of this 7, I'm going to divide both sides by 7. That'll get me to x plus 3 quantity squared equals 9. Now I'm going to square root, and that's going to leave me with the absolute value of x plus 3 equals 3. Then I'm going to take my two equations. I'm going to have one equation be x plus 3 equals positive 3. And my other equation is going to be x plus 3 equals negative 3. In order to solve this, I'm going to subtract 3 from both sides. So one solution is going to be x equals 0, or my other solution is going to be x equals negative 6. So a little complicated, but it's all skills that you already know how to do, just combined into one big problem. Why don't you try this next one on your own? So pause the video and see what you can do. All right, you're back. So again, we are trying to isolate the weird guy. Here's our weird guy, our x minus 1 quantity squared. So the first thing that you are going to do is you would subtract 4 from both sides. That's going to get you to 3 times x minus 1 squared equals 48. You're then going to divide by 3 on both sides, which is going to get you to x minus 1 squared equals 16. You're going to square root both sides, which is going to get you to x, oops, made a mistake here. Oh no, okay. We can recover here, guys. So we have x minus 1. Here we go. We're going to have x minus 1, the absolute value, equals 4. All right. So then I have my two equations. I'm going to have, we're going to erase all of this quick. There we go. All right. So we're going to have x minus 1 equals 4, or we're going to have x minus 1 equals negative 4. So I add 1 to both sides. So my two solutions are either going to be x equals 5 or x equals negative 3. Negative 3 there. All right. All right. So another one. What happens here? We're going to divide both sides by negative 3 because, again, we're trying to isolate the weird guy. When that happens, we are going to end up with x minus 1 squared equals negative 9. Then I'm going to square root and I'm going to square root. Right now, there should be fireworks going off in your head because you should realize that this is impossible. We cannot take the square root of a negative number. So the solution to this question is NRS. There's no real solution. All right, the last type of equation I want to show you is square root equation. So instead of us doing the action of a square root, the square root is already part of the equation. And in order to undo a square root, we are going to square, and whatever we do to one side, we do to the other. The square root and the square are going to cancel each other out. And here's why. If I'm going to take the square root of 9, I know that the square root of 9 is 3. Well, if I were to undo this, what if I squared both sides? Again, the square root and the square are going to cancel each other out, and I would get 9 equals 9. So when I square both sides here, I end up with x plus 7 equals 25. I would subtract 7, and I'm going to get x equals 18. So here, notice that I'm only looking for one solution. Okay, our square root equations, we're looking for one solution. All right, last one. So we are going to square both sides. This gets a little trickier with what I'm squaring, but it's the same idea. Everything inside comes down, and I square the other side as well. I add 1 to both sides, so I'm at 2x equals 10. Divide, divide, and my one solution is x equals 5. All right, so to recap, you've learned 3 types of special equations. You've learned absolute value of x, you've learned x squared, and you've learned, last but not least, our square root of x. So in all of these, your goal is to isolate the weird guy, and you're going to think negatively, looking for 2 solutions. And for these 2 specifically, you're focusing on your absolute value of x and your x squared equations. So both of these, you're looking for 2 solutions. Okay, and remember that your square root of x, you're looking for just 1. Okay, these guys, we're looking for 2. So hopefully this makes sense. If you have any questions, let us know, but good luck on your homework.